Welcome. In this video I'm going to show you how you can determine quantiles or quartiles or quintiles or any tiles with Microsoft Excel, not using the built-in function, so you have more options to actually choose from. Still using numerical data. I have a separate video if you have non-numerical data, and the easiest way would probably be to just use my add-in, which has a function that can do it all. But if you don't want to do that, here's how you can get more than just the basic functions. It's going to be a slightly longer video because there are quite a lot of different options. I'm using as some example data here. I just have a bunch of numbers. So those are filled out, and I want to have, let's say, quintiles. So I want 5 of them, and I want the fourth one. So the proportion is then simply 1 divided by 5 and then times 4. So at 80%. And the first thing I do is I count the number of scores that I actually have, which can simply be done with count A. And I need the data then sorted, and that's a little bit tricky to do, but it can be done. You can either just select and then use, I think it's under home, there's a sorting option. But if you don't want to do that, you want to keep the original order as well, you can type in an index number, or you can just copy it and then paste and then sort. But if you also don't want to do that and you just want to use a formula, type in the number 1 and then either just type in 1 to 8 as well. Or you can use this fancy formula which checks if this one is empty. If it is, then don't do anything. And otherwise look for the maximum value that has gone before. So that's why there are dollar signs on the B2. But not on the second one, so that when I copy it down, this B2 will change to B3, B4, etc. And add 1. If that's greater than my sample size, then don't do anything, and otherwise return that value. So it's just a simple way of getting the values 1 to 8 or 1 to n in general. Then I can use these to actually sort all of these. So this should be the smallest one. So I can use the function small, and then the smallest one is the first. So that's that one, and then it actually just here it will give me the second from smallest one, the third, the fourth, etc. So in essence, this is just data sorted. All right. Once we've done that, we can really get started. I want to have the index of this quantile. And there are different ways of approaching this. I found these different methods. They all employ somehow this proportion that you have and the sample size. And as you can see, the formulas slightly differ for each. They're relatively straightforward. The most complicated ones are the ones from Hindman and Van. So as you can see, that's still not that complicated to enter. Two slightly more specific ones for just quartiles. So those are the inclusive and the exclusive methods, sometimes referred to as hinges. They actually require an if statement. So if the number is even, so if you do modulo 2, the sample size, then you use this one, and otherwise you use this one. And that's for the first quartile. For the upper quartile, the third one, you can use this one. The exclusive method, similar, and you use those. So these are all possible indexes for the quantile that you're after. Now, depending on if this is an integer or a fractional, so for example here this one is an integer but the other ones are fractional. If it's an integer, there are actually two versions I've seen. Most of them will actually simply then say, well, then it's going to be that integer. So for this one, the 7th number, so we look up in here, we see there's the 7, so that should be the 18. But there's one that actually says, no, then take the midpoint. So the midpoint would simply be taking half of this one then, plus the next one, so 7 and 8. So in this case, that would be these two. So these two numbers, and then you take half of that. So that goes for any of these. So we can simply use that small little function. I have the same indexes here again. That's just a reference to over there. This checks if it's an integer. So if I round this value, do I get the same result? If so, then it's an integer. If not, it's not an integer. Then if it is an integer, I could either use the integer value. So, and then I can say, well, okay, if this is true, then just look up this value. I'm still rounding it to 0 decimals because for some reason sometimes it doesn't recognize it. It sees it as 7.0 or something. And then look up in column B and C, so that's these two columns. Return to me the second column, and I only want exact matches. Otherwise, don't do anything. For the midpoint, slightly more complicated, but not that much. I actually look up that same value again, but now also that value plus 1. So it looks up the next one and then divide that by 2. You might notice here there's an error here. I could say, well, if this is NA, then don't show anything, but it's because this is only for quartiles. The first two for first quartile, these for the third quartile. So basically, if I'm asking for 0.25 and I'm asking for 0.8, so that's why I'm getting the error there. Now, if it's not an integer, so if this is false, we have even more options. So what we could do then are the following things. We could again use the midpoint. We could use linear interpolation, or we can actually do some rounding. But let's first focus on these two. The midpoint is very similar. We just round then the fractional part down, so this will be 6. And we look at the value 1 higher, so that will be the 7th. So that's what's being done here. I'm actually looking at the lower and the higher ones. I'm just looking up this value rounded down, and then again looking it up in my BC, which has the index number and then the value. Return the second column and exact matches only. For high it's exactly the same, but then we round up. So this 6.4 becomes a 7, and then it looks that value up. Now for the midpoint, you simply take the average of these two, or you can say, well, so add this one plus that one divided by 2. For linear interpolation, you actually look at how far off is this from the lower value, so that's 40%, and then you also take 40% of this, and that's what this formula actually does. And here is that exact same one. So we take the original, the low value, and then we add the difference between the two. This one and the rounded down value, and that gives you the linear interpolation. All right, but like I mentioned, there's also other options, which is to round these values if they're fractional. And then rounding can be done in different ways. I've encountered these 5 versions, so either always round down, which is sometimes known as the floor function, always round up. You can use so-called banker's rounding, which means that if it ends at a half, you round to the nearest even integer. You can use nearest, which is simply to round 0.5 always up. And half down means to always round 0.5 down. I'm using these symbols to indicate these, and we can convert these last 3 to anything that has to deal with these. So for example, the banker's rounding, I have it over here. What you can do is you subtract if you subtract a half, and if that's modulo 2, if that's 0, so if it's then even, then you just round down the value, and if it's odd, you round it up. So in all other cases, you can just add a half and then round down that value. For the half down, what you can do is if it doesn't end with a half, you can simply add a half and then round down. And if it does end in a half, so modulo 1 equals a half, then you actually round down. You add a half, you round down, and then you subtract 1. Alright, so we can use all of these. So again, I'm having the original index value, the fraction, if it's a fraction or not. And then if I want to round down, Excel simply has a round down function. So I then round down the index and then look that value up again in columns B, C. I can also use the round up, for which Excel also has a function. Now the banker's method, that is a little bit longer. So the banker's method was this one. So we have 3 ifs in there. And so for the modulo, you can just use Excel's mod version. And then this shows you the banker's rounding. And for the nearest, similarly, we just round down the value. And that should be it for the nearest, because round, round is the default from Excel. And half down, that's where we can use this one. So we have again an if statement in there, which is simply checking if modulo 1 equals a half. If that's the case, then actually it's not using a half down. It's slightly different, this one. What I've done here is I checked if I multiplied by 2 and then round to the same value to 0. That's the same as checking if modulo 1 would be a half or not. If so, then round down, otherwise use normal rounding. Alright, and that's basically it. So now we have all our different options, and there are different methods. I've a few that I've come across. I've labeled them a little bit like this, and it shows which indexing method to use, what to do if the proportion that you're after is an integer, the index, and the proportion is less than 0.5. Similarly, you could perhaps do something else if the proportion is higher than 0.5 for integers, but none of the methods that I've come across have a different version for that. And note also that only this method actually uses the midpoint if it's an integer. Similarly, if it's a fractional part, you could choose any of the options we discussed earlier. And again, that might change, as you can see, for example, here. And depending on if the proportion is below 0.5 or above 0.5. And then if you want the next quantile, or whichever you're after, so I go all the way back and then say, well, I don't want the 4th quintile, I want the 3rd one, and then you repeat all the steps. Alright, this was a very long video, but yeah, there were tons of different options to go over. Hope this was helpful, and thank you for watching.